Hi guys, welcome back. We are trying to understand what is Kubernetes. Kubernetes is an orchestration platform. It is used to manage our containers. It is developed by Google using Go language. The first version released in the 2015. Earlier, Docker Swarm we used it to work with for orchestration, but the Docker Swarm having some challenges. To overcome those challenges, we are going for Kubernetes. In the Docker Swarm, auto scaling concept is not available, whereas in the Kubernetes, auto scaling concept is available. Right, for the production, Docker Swarm is not recommended because the scaling is a manual process. Whereas in the Kubernetes, scaling is an inbuilt process. So that's why we are going to use Kubernetes. Coming to Kubernetes architecture, it is going to follow cluster architecture. Kubernetes cluster we need to set up. In the cluster, as we have discussed, control plane will be available and worker nodes will be available. To communicate with the control plane, we can use web dashboard or we can use kubectl. Kubectl is a command line utility. By using that, we can communicate with the control plane. In the control plane, API server will be available, scheduler will be available, controller manager will be available, and etcd also will be available. Coming to the worker node, kubelet will be there, kube proxy will be there, Docker engine will be there, and we are going to create the pod. In the Kubernetes, pod is a runtime instance. Everything will be represented as a pod in the Kubernetes. Pod is called as smallest building block that we can deploy in the Kubernetes cluster. Inside the pod, our containers will be available. Got it. Now we want to set up the cluster. So Kubernetes cluster we can set up in multiple ways. Self-managed cluster will be available and managed cluster will be available. Self-managed cluster means we need to create the cluster and we need to manage that cluster on our own. So in two ways we can do that. One is by using Minikube. Second one is by using Kubedium. Minikube is a single node cluster. Kubedium is a multi-node cluster. Single node means, so we can't see the worker nodes and control plane separately. In one machine, everything will be managed. That is only for practice purpose, not for the real projects. For the real projects, we can go for Kubedium, multi-node cluster. We need to take multiple Linux machines and we need to set up the Kubernetes cluster in those machines and we need to take care of that cluster. But in the real time, we need a stable cluster and a high available cluster. That's why people will go for managed Kubernetes clusters. Cloud providers will give the clusters for us to run our application. So if you are using AWS cloud, in the AWS, there is a service called AWS EKS is available. AWS EKS is fully managed service in the AWS cloud, and that is the robust cloud that we can use. So you can run your applications on the AWS EKS cluster. Cluster will be managed by AWS. You just manage your applications. Now let us see how to set up that AWS EKS cluster in our AWS cloud. I have given a document to set up this EKS cluster, and diagrammatically also we have discussed how we are going to set up that cluster. Now first we need to create one machine as a client machine. That client machine we are using to set up EKS cluster in the AWS cloud. EKS client VM I am going to create first. That means one Linux machine I am going to take. In that Linux machine, I will install AWS CLI software, EKS CTL software, kubectl software. And for this machine, I will attach one IAM role with some policies. Then by using EKCTL tool, I will create the EKS cluster. Cluster will take 5 to 10 minutes of time to create. As we are creating cluster from this machine will maintain the kubeconfig data. Kubeconfig data contains our Kubernetes cluster information. All right, let's start with the process. The first step is launch new Ubuntu VM using AWS EC2 service. Now I'm going to my AWS account. So EC2 service, I will create one new EC2 instance with Ubuntu flavor. Launch instance. Now I'm taking this as EKS client VM. So by using this machine, I will communicate with the EKS cluster. That's why I'm naming this as EKS client VM. So Amazon Linux image available, Ubuntu is there. I'm going for Ubuntu. So in the Ubuntu, you can choose 22.04 or you can choose 20.04 Ubuntu server version. It is a free tier. I'm taking micro in T2 micro only. Right. Now T2 micro free tier eligible, key pair to login. I'm selecting my key pair, default network I'm going to use. So existing security group, I'm selecting that is default security group and launch the instance. So with this, EC2 instance got created. Let's connect it to this EC2 instance by using mobile extrum. The instance is getting started. The instance is getting started. Right. Go to this public IP, go to mobile extrum. Guys, all of you able to see my screen? Are you able to see my screen? Yes. Fine. I'm taking this public IP. Username is EC2 user. Sorry, it is Ubuntu. The username will be Ubuntu for the Ubuntu machines. If it is EC2 machine, I mean Amazon Linux, the username will be EC2 user. It is a Ubuntu machine, so username will be Ubuntu. SSH setting, private key, select the key pair and OK. Now, connected to this machine. Now, in this machine, we need to install the required softwares, right? So connect to this machine and install kubectl. So let us take this command and execute it. Now, after this, let us give the permission for that kubectl. It is still downloading that. Yeah. So once it is done, execute this command to give the permission. Then change the location of that kubectl to user local bin directory. Then check the kubectl version. Which version of the kubectl is installed? Yes, we can see version 1 of the kubectl software got installed. So with this, kubectl installation got completed. Then install AWS CLI latest version using below commands. Sudo, first we need to install this unzip software because AWS CLI will be downloaded as a zip. In order to unzip that, we need to have unzip software. I'm installing that by using apt package manager. Now, so you can go to this CD, you can check the directory of this CD, right? So current working directory is there. Next, go for this curl command, download AWS CLI. It is downloaded. Then unzip this AWS CLI. Done. Then install it by using this. Yes, you can now run AWS version. Now you can execute this, check this version of the AWS CLI. Yes, AWS CLI is installed. Then next, go and install EKCTL tool. EKCTL tool is used to set up EKS cluster. Right. Let us execute this command. Curl command I'm using to download EKCTL. Then change the directory to local bin. Then check the version of this EKCTL. Yes, 0.135 is installed. So with this, we completed installation of AWS CLI software, EKCTL software, and the kubectl software. Now, I need to create one IAM role and I need to attach that IAM role to my EKS client machine. Now, so for this IAM role, we need to provide some permissions. IAM full access, VPC full access, EC2 full access, CloudFormation full access, and administration access we need to provide. We need to create the IAM role. IAM stands for Identity and Access Management, which is used to manage users, groups, permissions, and roles. Create one IAM role with all these permissions and attach that IAM role to our EC2 instance that we have created. Now, go here, check with IAM. Now, so IAM service will open. There we have the option to create the roles. Right. You can create a new role. Click on create role, AWS service. select use case as EC2, click on next, then give the permissions here. What are the permissions? IAM full access. Search for the IAM, you will get IAM full access, select it. After selecting this, just click on the clear filter. Then go here, VPC full access. Type VPC and click on enter. You will get Amazon VPC full access. Now clear this. Next, EC2 full access. Amazon EC2 full access here. Select this, then clear the filter. You can see how many we have selected. As of now, we have selected 3. Another 2 we have to select. CloudFormation full access. Search for this. Amazon AWS CloudFormation full access. Select this. Then administrator access. Type admin, enter. Now here we need to give administrator access. Select this and clear the filter. With this, we have selected all the roles that are all the permissions that are required for our role. So you can see selected 5. Then go to next. Here you can give the name. You can give any name for the role. I'm giving EKS role for EC2. EKS role for EC2 and click on create the role. Before clicking on the create role, you can see what are the services, what are the permissions that we have added for the role. IAM, VPC, EC2, CloudFormation, and administrator access. With this, click on create role. Now, role will be created. Role will be created. Yes, you can see role EKS role EC2 got created. You can check the role which you have created. Yes, in that role, what are the policies we have attached? We can see those policies also. Once the role is created, attach created role to EKS management host. How can we attach that? Go back to our EC2 service. Now, EC2 instance, we have EKS client VM. Select this machine, then actions, security, modify IAM role. I have given these steps in the document. Select this EC2 instance to which you want to add the IAM role. Go to action, go to security, go to modify IAM role. So here you can see the roles we have created. So this is the role that I have created, EKS role EC2. Then click on update IAM role. So with this, IAM role got updated for our EC2 instance. Fine. With this, we are good. Then next step, create EKS cluster using EKS CTL command. Already we have installed EKS CTL utility in our machine. Using that utility, we can create our EKS cluster. So in order to create the EKS cluster, this is the syntax of that command. EKS cluster, what is the name of the cluster? In which region you want to create the cluster? What type of worker nodes you want to attach for that cluster? And what are the minimum number of nodes you want? What are the maximum number of nodes you want? That you can pass as an input for this EKS create cluster command. So by using this EKS CTL, we can create the cluster as well as we can delete the cluster also. Now, when we want to create the cluster in the Mumbai region, we need to give the region code. In the AWS, there are several regions available. For every region, one code is available. For the people who are staying in India, you can use Mumbai region. You can create the cluster using this command. The people in the US, you can use North Virginia region and you can create the cluster. Now here if you see EKS CTL create cluster, -1 name, Ashok IT cluster 4 region. This is my cluster name. You can give any name for the cluster. EKS CTL create cluster, name of the cluster, in which region you want to create the cluster, what type of machines you want to use for the worker nodes. I want to use a T2 medium so that high availability and performance will be good. Then zones, in that Mumbai, there are 3 zones available, South 1A, 1B, 1C. I'm using 1A and 1B, right? So after executing this command, it will take some time to create the cluster. Now you can check this kubectl get nodes command. I have not created the cluster as of now, just I'm executing this command. When I am executing this command, what it is telling, kubectl get nodes, connection to the server was refused. Did you specify the right host or port? So as of now, my cluster is not available. That's why this command is not giving me any output. Now, let me take this command, eksctl create cluster, my cluster name and Mumbai region I'm using. Now, so this is the command. I'm executing this command. Now, it is using that eksctl to create the cluster. My cluster creation is in progress. Now deploying the stack eksctl Ashok IT cluster 4. So the cluster is getting created, right? So it will take 5 to 10 minutes of time to create the cluster. Internally, it is using CloudFormation to deploy all the resources that are required for the cluster. Okay. Waiting for the CloudFormation stack. As we discussed, it will take 5 to 10 minutes of time to create the cluster. Right. Once the cluster creation got completed, here in this machine, kubeconfig file will be updated. So what is this kubeconfig file? Kubeconfig file contains the cluster configuration details. That means what is the location of the cluster, what is the URL of the cluster. That cluster configuration data will be available in the kubeconfig. That kubeconfig file will be created in our EKS client VM. So that our EKS client VM can use kubectl software to connect with the cluster. Kubectl software will identify the cluster location by using this kubeconfig file. If you delete the kubeconfig file, then your machine cannot communicate with the cluster. Right. Still, the cluster creation is in progress. It will take 5 to 10 minutes of time. Fine. So meanwhile, let's try to understand what we are going to do once this cluster got created. So once this cluster got created, we need to create our application deployment in the cluster. As we discussed, application deployment in the cluster, nothing but we are using kubectl software. It is there in another machine. By using this kubectl software, I need to deploy my application. When you want to deploy the application, you need to create a pod. In the Kubernetes, everything will be represented as a pod. Okay, guys. Now, let us try to understand the basic components that we need to learn in the Kubernetes. Kubernetes components. Guys, when it comes to the Kubernetes, we should understand pod. What is pod? How to create a pod? And second one is services in the Kubernetes. Third one is namespaces in the Kubernetes. And the fourth one is replication controller in the Kubernetes. And the fifth one is replication set in the Kubernetes. And the sixth one is daemon set in the Kubernetes. And the seventh one is deployment in the Kubernetes. Eighth one is stateful set in the Kubernetes, right? And the next one is config maps and secrets in the Kubernetes. Config map and secrets in the Kubernetes. And the next one is ingress controller in the Kubernetes. And we need to understand what is Helm in the Kubernetes, Helm charts in the Kubernetes, okay? And Kubernetes volumes we need to understand, Kubernetes volumes, right? And we need to talk about Helm charts in the Kubernetes and how to monitor the Kubernetes by using Grafana and Prometheus, okay? And we need to understand ELK setup in Kubernetes for log aggregation. We need to go for that. And the fifth one, RBAC will be there in the Kubernetes for role-based access. These are the most important concepts related to Kubernetes. And web dashboard setup, how to execute our applications on the cluster from UI. Currently, we are using eksctl, right? So Kubernetes web dashboard concept will be available. By using that web dashboard, also we can communicate with the cluster. Okay, guys. Now, pod, services, namespaces, replication controller, replication set, daemon set, deployment, stateful set, config map and secrets, ingress controller, Kubernetes volumes, Helm charts, Grafana and Prometheus, ELK setup, RBAC, and web dashboard concept will be available in the Kubernetes. Now here guys, first, what is pod in the Kubernetes? What is pod in the Kubernetes? Everything will be represented as a pod in the Kubernetes. So here, let's try to understand pod. In the Docker, everything will be represented as a container. In the Kubernetes, everything will be represented as a pod. So what is the pod in the Kubernetes? Pod is a smallest building block. Pod is a smallest building block that we can create in the Kubernetes cluster. Pod is a smallest building block in the Kubernetes cluster. In Kubernetes, every container will be created inside the pod. In Kubernetes, every container will be created inside the pod. If you want to deploy your application, then your application deployment will happen by creating the container. Where that container will be created? That container will be created inside the pod only. Pod always runs in a node. Pod always runs inside node. Right? You have a worker node. Always your pod will be running on the worker node. It will not run on the master node directly. Pod always runs on the node. Pod represents running process. Pod represents running process. So now I want to deploy one Spring Boot application. So by using kubectl, I will send a request to the control plane to deploy my Spring Boot application. API server will take my request, will store in the etcd. Scheduler will go to the kubelet and will understand the worker node's information. In which worker node our application should be deployed. Then controller manager will perform that action. Then for our application, one Docker container should be created. The Docker container will be created inside the pod. So what is that pod? Pod is a smallest building block in the Kubernetes cluster. In Kubernetes, every container will be created inside the pod. Pod always runs inside the node, right? Pod represents running process. Pod represents running process. Okay. Pod is a group of one or more containers running on a node. Pod means group of containers running on a node. So inside the pod, you can run one container or you can run multiple containers. Each pod, we can create multiple pods on the single node. We can create multiple pods on single node. Every pod will have its unique IP address. Every pod will have unique IP address. Every pod will have unique IP address. So now how to create the pods? We can create the pods in two ways. We can create pods in two ways. So what are those two ways? One is by using interactive approach. Second one is by using manifest YML. In the Kubernetes, if I want to deploy my application, then I need to create a pod. So pod is a smallest building block in the Kubernetes cluster. Everything will be represented as a pod in the cluster. Pod will always run inside the node. Pod represents running process. Pod means group of containers running on the node. We can create multiple pods on the single node. Every pod will have unique IP address. We can create pods in two ways. One is by using interactive approach. Second one is by using manifest YML. So now, how to create the pod in the interactive approach? So here syntax will be available. kubectl is a command. kubectl run --name. What name you want to give for the pod? We'll give the pod name. And what is the image that we need to use for the pod creation? That image name we are going to provide. Okay. And I want to run the pod. For that, we need to use a generator is equal to pod/v1. Pod version 1 I need to use in order to run the pod. So this is my Docker image. For the Docker image, I want to create a pod. Because in the Kubernetes, containers cannot be created directly. In the Kubernetes, everything will be represented as a pod only. So to create that pod, we have two options. One is interactive approach and the second one is manifest YML. So here, this manifest YML that is called as declarative approach. We can say that it is a declarative approach. That is Kubernetes manifest YML file. In Kubernetes, we are going to deal with the YML files to deploy our applications. Are you guys clear? What is pod now? Pod is the smallest building block in the Kubernetes cluster. Every container will be created inside the pod. Pod always runs inside the node. Pod represents a running process. Pod means group of containers running on the node. We can create multiple pods on the single node. Every pod will have unique IP address. We can create pods in two ways. One is interactive approach and the second one is declarative approach. Okay, guys. Now, let us see here. Guys, in the real time, we are going to use Kubernetes manifest YML files to create the pods. So Kubernetes manifest YML syntax. Kubernetes manifest YML. So what will be there in this Kubernetes manifest YML? Mainly in this manifest YML, 4 sections will be available. What are those 4 sections? First one, API version. And the second one is kind. Third one is metadata. And the fourth one is spec. Now here, this pod manifest YML will start with 3 hyphens and will end with 3 dots. So it represents starting point of the YML and it represents ending point of the YML. So this is Kubernetes manifest YML. By using this Kubernetes manifest YML, we are going to create the pod. Okay, guys. So in the Kubernetes, if you want to deploy your application, you need to create a pod. To create the pod, there are 2 approaches available. One is interactive approach and the second one is the declarative approach. So we are going to use the declarative approach here. Declarative approach means we are going to write the Kubernetes manifest file. In the manifest YML, there are 4 sections available. One is API version, second one is kind, third one is metadata, fourth one is spec. Right. Fine. Let me write one sample pod manifest YML to deploy one of our application. Okay. Kubernetes pod manifest YML. Kubernetes pod manifest YML. Guys, first and second YMLs, you may get some questions on that, but going forward every day, we are going to work with this YML. I will explain what is YML also, then you will get more clarity. For time being, just I'm writing one sample YML to deploy our application in the Kubernetes cluster. Kubernetes pod manifest YML. Now, as we discussed, YML files will start with 3 hyphens and they will end with 3 dots. So this represents start point of the YML. It represents end point of the YML. Now, in this YML, as we discussed, 4 sections will be available: API version, kind, metadata, spec. And remember, guys, as a DevOps engineer, we should be able to write these YML files. In the interview, they will ask you to share your screen and write the pod manifest YML. So you should be confident on writing these YMLs, Docker files, and Kubernetes manifest YMLs. You should have more clarity on this part. Now, see, first I'm going to specify API version. Then kind will be available. Then metadata will be available. Then spec will be available. So these are the 4 sections that we are going to specify in the manifest YML. By using this manifest YML, we need to create our pod. By using this manifest YML, we need to create our pod. So first I'm taking API version. API version is V1 and kind. So API version represents which version of the Kubernetes manifest files we are using. I'm using version 1, V1, kind. What is the purpose of this manifest YML? That will be represented by the kind. By using this manifest YML, I want to create a pod. So kind is the pod. API version, that is V1. And what is the purpose of this manifest YML? The purpose of this manifest YML is to create a pod. Kind represents pod. And the next one, metadata. Under the metadata, what is the name that you want to give for the pod? I want to give the name as Java Web Application Pod. Metadata, nothing but data about the data. You can give any name for the pod. So here, I want to give the pod name as Java Web Application Pod. Name can be anything. After this, for the pod, we need to give label. Label is nothing but a ID for the pod. So I'm giving the pod label as app Java Web Application. In the Kubernetes manifest files, labels are going to play very important role. Guys, see here, API version is the V1, kind is the pod, metadata. Inside the metadata, name I am writing and labels I am writing. Inside the labels, app I am writing with Java Web App. Now here, I'm giving some space. This is syntax of the YML. This space is called as indent space. This space is called indent space. This space is called indent space. This space is called indent space. I'm not giving these spaces. I'm giving these spaces as per YML syntax, guys, right? So if I write a name like this, that is invalid. So metadata should have the name. So name is a child for the metadata. App Java Web App, that is a child for the label. So for the pod, I'm writing a metadata. In the metadata, I'm writing the name. The name of the pod should be Java Web Application Pod. And what are the labels for that? App : Java Web App. This is a identifier of the pod. So now when you join in the company, you have a name and they will give you an employee ID. What is the meaning of that employee ID? Every employee will have a unique ID. Every employee having a name. Similarly, for the pod, I am giving the name. Along with the name, we will get one ID also. That is called employee ID. Similarly, when we are creating the pod, under metadata, we will set the name for the pod and we will set the label for the pod. These labels are very important when we are working with Kubernetes pods, right? Now, under metadata, I have given name for the pod and I have given label for the pod. Then next one, coming to spec. Here, spec represents what container you want to create. Now, containers information will be available under the spec. Under these containers, I want to specify, I want to create a container with a name called Java Web App Container. So now I'm writing a pod manifest. Using this pod manifest, what I want to do, I want to create a container. Container information will be represented by using spec. Containers, name of the container, Java Web App Container. To create this container, what is the image? So the image is available in my Docker Hub account. Ashok IT / Java Web App is my image name. Now, what is the port mapping for that? Ports. So here, the port mapping, the container port is 8080. The container port is 8080. So this is our pod manifest. In order to create a pod in the Kubernetes cluster, then you need to execute this pod manifest YML. There are 4 sections available. One is API version, second one is kind, third one is metadata, fourth one is the specification. API version, that is, what is the pod version that you want to use in this manifest? Version V, version 1. What is the purpose of this manifest? I want to create a pod. Kind represents what you want to create with this manifest. I want to create a pod by using this manifest. Are you guys clear with my point? API version is V1. Kind is the pod. Metadata, nothing but data about the data. So I want to create a pod, and for the pod, I want to give the name like this. And for the pod, I want to give the label like this. So name and label, both are different. Pod is having a name and pod is having a label. Label is nothing but a unique identifier to identify our pod. In the company, so many employees will be available. Every employee will have a name, right? So every employee will have a name, but company will give unique ID for every employee to identify that employee at any point of time. Similarly, for the pod, name will be available and label also will be available. Label is used to identify that pod, right? The next one, spec. Spec represents containers information. So here, containers I'm telling. That means we can create multiple containers inside the pod. So if I'm writing like this, one container will be created. So what is the name of the container? web app container. What is the image? To create the container, I'm using my Docker image. So earlier, we created Docker container by using Docker image. Now, I'm giving this Docker image to my Kubernetes pod manifest YML, and Kubernetes will create the pod. Inside the pod, my container will be created. For the pod, I'm specifying container port 88. That means my container will run in the my container will run on the port number 8080. Now my cluster is also ready, guys. We can see my cluster creation also got completed. You can see that kubectl command work with home ubuntu.kube config try kubectl get nodes. Now, so here my pod manifest YML is also ready and my cluster is also ready. Let us go for kubectl get nodes command. When I execute, sorry, spelling mistake, kubectl get nodes. When I execute kubectl get nodes, you can see 2 worker nodes are created and those 2 worker nodes are running. 2 worker nodes, nothing but 2 EC2 instances are running. You can see here, earlier I have only my Linux VM and I have my client VM. But a total now 4 machines are running. In those 4 machines, you can see Ashok IT cluster for machine 1, Ashok IT cluster for machine 2. So these are T2 medium instances. So 2 worker nodes got created. If you delete these worker nodes also, another 2 worker nodes will come because that Kubernetes cluster is using auto scaling concept internally. If you delete one machine, another machine will be created. So that is the meaning of cluster. So that worker nodes are running and the worker nodes are connected to our control plane. So now, how my machine is able to get this cluster? How my machine is able to get this cluster data? If you see ls-la, you can see that there is one LA nothing but to show the hidden files also. There is one directory created with a name called .cube. Okay. If you go to cd space .cube, ls-la, in the .cube, there is a config file is available. vi config. Now, this is our cluster information. API version cluster is available. So this is our cluster data and this is our cluster URL. This is our cluster URL. So don't change anything in this kube config file, guys. If you change this kube config file, then your cluster will not work. So now we can see the kube config file is created. So where is that kube config file? In our home directory only, that kube config file is created. ls-la .cube is available. Inside the .cube, that config file is available. cat.cube/config. If you execute this command, you can see our Kubernetes cluster information. So as our cluster information is available in our EC2 client VM, EKS client VM, our client VM can connect with the cluster by using kubectl. Now I installed kubectl utility in this machine. So and kube config file is also available. Where is this kube config file is created by default? By default, it created on /home/ubuntu. This is our home directory. In that .cube is created. In that config file is available. Inside the .cube config file is available. This is the default location of our kube config file. This kube config file contains our cluster information. So now when I execute kubectl command, then that kubectl will send the request to the cluster. Okay, guys, good. Our cluster is running. It is up and running. Fine. Now I have my Kubernetes pod manifest YML. This manifest YML is used to create the pod. It is used to create the pod. So API version, kind, metadata, spec. Inside the metadata, name is available and a label is available. Inside the spec, containers are available and container name and container image and what is the port number. My container port is 8080. Once this pod manifest YML is ready, first let us execute a command called kubectl get pods. Kubectl get nodes command is used to identify what are the nodes available in our cluster. How many nodes are available in our cluster? Worker nodes basically. Kubectl get nodes command will give you the worker nodes which are created in our cluster. So there are 2 worker nodes available and control plane is available. Sir, can we see that control plane? Can we manage that control plane? No, you cannot see that control plane when you go for EKS cluster. This control plane will be completely managed by AWS. You cannot manage the control plane. Control plane will be taken care by AWS. This is EKS control plane is fully managed by AWS. You cannot see that, right? You can see only worker nodes, but you can communicate with the control plane by using kubectl, right? We don't have any control on the control plane. We can't do anything with the control plane now. We can't manage that control plane because it is fully managed by AWS. We have control on our worker nodes, right? Now, my kubectl utility is ready and my pod manifest YML is also ready. First, I am going to execute a command called kubectl get pods command. When I execute kubectl get pods command, what it is saying that no resources found in the default namespace. Pods, your pods are not available in the cluster. No pod is running on the cluster. So there are 2 nodes available in the cluster, but there are no pods available in the cluster. To check the nodes, we will go for kubectl get nodes command. To check the pods, we will go for kubectl get pods command. Now I want to create a pod. In order to create the pod, we will go for a command called kubectl apply -f pod YML. Pod manifest YML, we need to provide as input for kubectl apply. Now, here I'm having my pod manifest YML. Let me take this YML. Let me create one file, vi pod.yml. You can give any name for that. I'm giving the name as Java web app pod.yml. Now, give this information in this YML. So this is my pod manifest YML. API version is available and metadata is available. Okay, guys, API version is available and metadata is available. Right. The spaces are very important here. Whatever the spaces that we are writing, those spaces are called as indent spaces in the YML. So first let's understand first pod creation. Then we will talk about what is that YML and YML syntaxes. API version is v1, kind pod, metadata, name is Java web app pod, label Java web app Java web app is the label I'm giving. Container, I want to create the container. To create the container, this is the image I want to use. And what is the container port? Container port is 8080. This is my pod manifest YML to create the pod. Inside that pod, container will be created. To create the container, this is the image it has to use. Now, save this YML. After saving this YML, let us try to create the pod. If the YML syntax is correct, then pod will be created. kubectl apply -f pod manifest YML, Java web app pod.yml. Perfect. Our pod got created. You can see the message here, pod/Java web app pod got created. How to check whether pod is created or not? Pod is created or not, we can check that by using kubectl get pods. When I execute the command kubectl get pods, so you can see the name of the pod 1 out of 1 pod is created. I ask you to create 1 pod, 1 out of 1 pod is created. The pod is in the running status. Pod created 17 seconds ago. Right. Now in my cluster, there are 2 worker nodes available. In these 2 worker nodes, in which worker node our pod is created? Pod is created. That's fine. By using this Kubernetes manifest YML, I created a pod. So this is my manifest YML. Using that manifest YML, I created a pod by using this command. So my pod is created. Where the pod will create? Pod will create in the worker node. Where the pod is created? Pod is created in the worker node. In which worker node that pod is created? We need to verify that. Now see the command first, kubectl get pods. So kubectl get pods will tell you how many pods are running, what is the status of the pod. Now, if you want to get the more information about the pod, you can go for kubectl describe pod. kubectl describe pod. Describe pod. What is the pod name? Java web app pod. Like this, you can get the information about the pod. Where the pod is running now, what is the pod information? You can see the name of the pod is Java Web App pod. The namespace is the default for that. This is the node. In this node, our pod is running 192.168.46.198. That is the internal 192.168.46.198. That is our node IP. Go to the nodes here. This is my first node. 192.168.46.198 and go to this second worker node. Now 192.168.18.197. Okay, 18.197. It is running in the first worker node 198. Now let me select the worker node 192.168.46.198. This is the IP, private IP of my worker node. This is my EC2 box. Worker node is nothing but EC2 box. So there are two worker nodes available. In these two this is first worker node and this is the second worker node. You see the IP address 192.168.46.198. So in this worker node, our pod is running. Guys, are you able to understand how to check what are the pods available and how to check in which worker node the pod is running? Yes, kubectl get pods will give you what all the pods running. kubectl describe pod Java web app pod. So kubectl describe pod Java web app pod. This command will describe the pod information. So what is the name of the pod and in which worker node the pod is running? What is the label of the pod? What is the status of the pod? And what is the pod IP? Every pod will have unique IP. Every pod will have a unique IP. Inside that pod, how many containers are running? Inside that pod, Java web application container is running. This is the container ID and this is the image we used to create that container. And this is the image ID. This is the port number, container port number. Host port is not available. What is the status of the container? Container is running. Container is ready. Container is ready. What are the mounts? Kubernetes service account is available. Conditions. What are the volumes available? Events. How the pod is created. Started the container, Java web application container, created the container and successfully pulled that image, successfully assigned default Java web app pod. So here, whenever I execute kubectl apply -f command, now you see it has taken that the scheduler has taken that successfully assigned the pod creation to particular node. Who is doing that? Scheduler is doing that. Then who is doing this kubelet? What is the kubelet is doing? Node agent. It is pulling that image and kubelet pulled that image successfully. Kubelet created that container and kubelet started that container inside the pod. Who is doing what action also we can see here. Got it. So what is the command I have used to see pods? kubectl get pods is the command to see the pod. Yes, Java web application pod is running. Next one, kubectl describe pod name. Right. So kubectl get pods to check the pods available. kubectl apply -f pod yml, create the pod and describe the pod. To describe the pod, we can go for kubectl describe pod with the pod name. When we are giving a name for the pod, with that name our pod is created. With that pod name, we can describe the pod. Now we can check logs of the pod. Sir, how my container got created? What are the logs of the pod? kubectl logs pod name. What is the pod name? Java web app pod. You can check the logs of the pod. If you check the logs of the pod, that means my Java web application got deployed in the Tomcat server. Here I'm giving the image name as Ashok IT Java web app. With this image, a container created. In that container created inside the pod. So to check the logs of the pod, we can go, if the pod is not creating, you can troubleshoot the issue by using logs. kubectl logs pod name. By using this pod name, you can get the logs of the pod. So when you check the logs of the pod, you can see what is happened inside the container. Right. Inside the container, our application is running. That is a Tomcat server. In that image, Tomcat server and Java web application is available. My application deployed in the Tomcat server. Good. Now, after this, simply you can also execute a command like this. kubectl get pods -o -wide. -o-wide. This will tell you unable to match suitable for the -o wide. -o wide. Right. When I execute -o wide, it will tell you your pod is running in which worker node. Simply you can get the node information. So by using -o wide option, this is the command we can use. What is the name of the pod? What is the status of the pod? When the pod is created? What is the pod IP? In which worker node the pod is running? All that information we can get from the cluster. So if you go for kubectl describe the pod, it will give you the complete pod information. If you execute this command, kubectl get describe the pod with the pod name. We have already given that. Now I want to get the pod only pod IP and node IP. kubectl get pods -o wide. So when you execute kubectl get pods, it will give you just name of the pods and status of the pods. It is used to create the pod by using pod manifest YML. kubectl describe the pod name. So kubectl describe pod name. What is the meaning of that? It is used to describe the pod. So what is the pod? What is the pod name? What is the pod IP? In which node pod is running? What is the container available in the pod? What is the container ID? Which image is used to create the container? What is the container port number? Everything we can check by using this describe pod command. If you want to see how the pod is created, what is the logs of the pod, then you can go for this logs command. I want to check what is the pod IP and what is the node IP and what is the status of the pod. Simply you can go for kubectl get pods -o wide. Are you guys able to understand what is pod and how to create the pod in the cluster? Pod is a smallest building block in the Kubernetes cluster. In Kubernetes, every container will be created inside pod only. Okay, without pod, there is no container. Pod always runs inside the node. Now, here, who is deciding in which node our pod should be created? That is decided by scheduler. Okay, and who actually created that container inside the pod? Kubelet. Kubelet is a node agent. Who is downloading our Docker image? Kubelet is downloading the Docker image. Right? Next one. Pod can have more than one container also. Currently, I created one container inside the pod. How many ways we can create the pod in the Kubernetes? We can create the pod in two ways. One is interactive approach and the second one is declarative approach. Right. In the declarative approach, we are going to use manifest YML. Manifest YML. So here in the manifest YML, what information is available? In the manifest YML, API version, kind, metadata, spec, like that information is available. Okay, guys. Now, here, in order to check the pods which are running, we can go for a command called kubectl get pods command. So to create the pod using manifest YML, you can go for kubectl apply -f pod YML. kubectl apply -f pod YML. That is used to create the pod based on the manifest YML. That is used to create the pod based on the manifest YML. Got it? We can check the logs of the pod by using kubectl logs. You can check the nodes in which node the pod is running. You can go for kubectl get pods -o wide. Now here, guys, pod is created. Inside the pod, my application is also running. Now, how to access our application? Can I access my application running in the cluster? In this cluster, where is my application is running? In this application, where is my application? In this cluster, where my application is running? Guys, and can we see master node in the EKS cluster? Can we see master node in the EKS cluster? No. Master node nothing but control plane. Who will manage that control plane? AWS will manage the control plane. We can see only worker nodes. Control plane will be taken care by AWS. Got it? Now, in this cluster, my pod is created. Where my pod is created? In which node my pod is created? Pod created in control plane or pod created in the worker node? Guys, pod created in the control plane or pod created in the worker node? Pod created in the control plane or pod created in the worker node? In the worker node. In which worker node the pod is created? In which worker node the pod is created? In the first worker node the pod is created. Okay, guys. Fine. Now, pods we cannot access outside. Now my application is accessible outside or my application is not accessible outside? My application is accessible outside or my application not accessible outside? Pods we cannot access outside. You got my point? Pods we can't access outside. Now my application, our application is running in the cluster now. How to access our application? We cannot, because pods are internal to the cluster. Pods we cannot access outside. To expose the pods, we need to expose pods for outside access using Kubernetes service concept. Okay, my pod is created. My pod is having a name. My pod is having a label, but the pods are not accessible outside. What I need to do is, by default in the Kubernetes, pods are specific to within the cluster. Pods are only accessible within the cluster. The pods are not accessible outside the cluster. Pods are not accessible outside the cluster. Now, this is our pod IP. This is our pod IP 8080. This is our pod IP, right? Can I access this pod outside of the cluster? This pod cannot be accessed outside of the cluster. That means my application is not accessible outside the cluster. In order to access our application outside the cluster, we need to expose pods for outside access using Kubernetes service concept. Okay, guys. So now what is Kubernetes service? Kubernetes service is used to expose pods outside the cluster. Kubernetes service is used to expose pods outside cluster. We have three types of Kubernetes services. First one is called cluster IP. Second one is node port. Third one is load balancer. So like that, there are three services available in the Kubernetes. So they are, first one is a cluster IP, second one is a node port, and third one is load balancer. So what is the purpose of these services in the Kubernetes? So these services are used to expose pods outside the cluster. Okay, guys. Now, to expose the pods outside the cluster, we need to create service manifest. How we created the pod manifest, similarly, we need to create a service manifest. Pod manifest should be available, service manifest should be available. So pod manifest is used to create the pod. Service manifest is used to expose the pods outside the cluster. Are you guys able to follow me? What is pod and what is a service? Are you guys able to follow me? What is pod and what is service? Yes. What is the service in the Kubernetes? What is service in the Kubernetes? Service is used to expose pods outside cluster. Okay. How many types of services we have in the Kubernetes? We are having three types of services in the Kubernetes. What are those three types of services in the Kubernetes? One is a cluster IP, second one is node port, and the third one is load balancer. Cluster IP, node port, and load balancer. Now, to expose pods using Kubernetes service, we need to write service manifest YML. We need to write service manifest YML to expose pods. Okay, so this YML, 3 hyphens and 3 dots. Here also same procedure. API version will be available, kind will be available, and metadata will be available, and spec will be available. Spec will be available. API version, that is V1. Kind, I want to create a service in the Kubernetes. Earlier we have given the kind as pod because I want to create a pod. Now I want to create a service, right? API version is V1, kind is a service. In the metadata, I will write the name as Java Web Application Service. Okay, next one, coming to the spec. Spec is used to identify what is the label of the pod. This service is used to expose a pod. So where is the pod available? Now, what is the service type? I want to give the service type as a node port. So there are 3 types of services available. One of the service type I am giving as a node port. Okay, we will understand the services in the coming sessions. Currently I am using node port service. And selector. Selector is used to identify pod by using label. What is the label I have given for the pod? App::Java web app. Now, in the service, I am specifying a selector. Service selector should identify the pod by using pod label. Labels and selectors are very important in the Kubernetes. Selector app::Java web app. Now, what is the port mapping here we need to do? Right. Container port is 8080. Right. I want to map that port to 80. Now, my host port is 80. My target port is 8080. Target port represents our container port. This is my host port. So this is called our service manifest. Okay. So currently you can check here what are the services running. kubectl get service. Services are running, only Kubernetes service is running. Our application service is not running. To run our application service, we need to execute this manifest YML. This is our service manifest YML. What is the purpose of this service manifest YML? This service manifest YML is used to expose the pods as a node port service. Okay, how this service manifest will know which pod it has to expose? Here, service having a pod selector. Selector is representing label of the pod. So here, whatever the label you are giving, the same label you need to write here in the service selector. Okay. Now, pod manifest YML is available to create the pod. Service manifest YML is available to expose the pod as a node port service. Okay, guys. Now, let me take this YML. Let me take this YML. So ls-l. Currently, I'm having Java web app pod.yml. Now I will create Java web app service.yml. Right. Inside this YML, I'm going to keep my manifest YML. Okay. Now this is my manifest YML to create a service. What is the name I am giving for the service? Java Web Application Service. Name can be anything. Port mapping, and this namings and alignment is very important. API version is V1, kind is a service, metadata web application service, spec type is a node port, selector Java web app. This is important, guys. This is a label of the pod and ports. So I am giving host port as 80 and target port is 8080. Fine, save this file. Then let us check this. Here I am having service YML. Let us create the service here by using kubectl. kubectl apply -f Java web app service.yml. It should create a service. So there is a problem. Port, if you choose to ignore the errors, I think ports, there is a mistake in the YML. Let me edit that. For the ports, I have given capital P. Let me give it as small p. Okay, ports. Save it. Now, let us execute service YML. Yes, with this my service is created. How can I check my service is created? kubectl get service. kubectl get service. Yes, my service is created. Java web application service. My service is created with a node port. And for that node port, it has given a random number 30785. So my application running on the port number 30785 now. I need to enable that port number in the security group. Go to that machine and check what is the security group attached to that machine. First worker node security group is available. So this is the security group of that machine. In that security group, in the inbound rule, I need to enable, add the rule, custom TCP. What is the node port number I got? 30785. It is a random node port it has given. We can fix that port also. We'll discuss in the coming classes. 30785 I have given. Save the rule. Fine. I have saved, I have enabled the node port which is generated for my service. My service is exposing the ports. Okay. Now let me go here and let me try to access my application. Public IP colon 30785/Java web app. Perfect. I'm able to access my application which is running in the Kubernetes cluster. So I have created a pod. That pod I have exposed as a node port service. For that node port service, it has given 30785 as a random node port number. That node port I enabled in the security group of that worker node. Then I'm able to access my application. Can you guys check this? Are you able to access my application running in the Kubernetes cluster? Can you guys check this? Are you able to access the application which is running in the Kubernetes cluster? Yes, we are able to access. Now, where is my application running now? In my worker node. My application running as a pod. Can we access the pods outside the cluster, or we cannot access the pods outside the cluster? Can we access the pods outside the cluster, or we cannot access the pods outside the cluster? No, we cannot access the pods outside the cluster. How I am exposing my pods outside the cluster? How I am exposing the pods outside the cluster? By using Kubernetes service. How many types of services available in the Kubernetes? There are 3 types of services available in the Kubernetes. What are those 3 types of services? One is a cluster IP, second one is a node port, third one is a load balancer. Today, which service type I have used? Node port service. Now, here you can execute a command kubectl get svc. It is used to display existing services. Display existing services. Now, I want to create a service. Create Kubernetes service. Now, for that we will use kubectl apply -f service manifest YML. That's it. kubectl apply service manifest YML. So after creating, then you can execute this service, get the services which are available. So we can see service information. We can see service information and node port number assigned by Kubernetes. Enable node port number in security group of worker node in which our pod is running. How to check in which worker node your pod is running? You can check in which worker node the pod is running by using kubectl get pods -o void. So it will give you the IP address of your node. And how to check what is the node port of our application? kubectl get service. So kubectl get pods -o void will give you in which worker node your pod is running. And when you execute kubectl get service, So this is your service name. It is a node port service and it is running with which port number? 30785. Now you should go to this worker node machine. In that machine security group, you need to enable 30785 port number. After enabling that, then we can access our application in the browser. Access application. Access application in browser. So what is the URL to access our application? http:// node public IP node port number / Java web app. So with this URL, our application will be accessible in the browser. I'm able to deploy my Java web application as a container in the Kubernetes cluster. But actually Kubernetes is not creating the container directly. I have requested the Kubernetes to deploy my Java web application. Kubernetes created container inside the pod. Pods are not accessible outside. We need to expose the pods outside. To expose the pods outside, I am using Kubernetes service. There are 3 types of services in the Kubernetes. I have used node port service today. Tomorrow, I will explain what is the difference between the remaining services and when we will go for the remaining services also. Okay, guys. Are you clear with this? Now, here, whatever the manifest files I'm having here, I will give you those manifest files. You can use them. Cat Java web app pod.yml. So this is my pod manifest. It is working. I created my pod by using this pod manifest YML. Thus, these alignment and naming conventions and spaces are very, very crucial in the Kubernetes manifest. svc.yml. This is my service manifest. We are creating pod manifest. With that pod manifest, we created the pod. We created service manifest. With that, we created a service. Display all pods which are created. Okay. Now create the pod. Create pods using pod manifest. Describe the pod. Get more info about the pod. By using describe command, we can get more information about the pod. Get the pod logs. Pod logs, nothing but basically container logs. Get the pod logs. Check pod is running on which worker node. Get worker node info of get pod running on which worker node. Get the pod running on which worker node. As a DevOps engineer, you should be very strong in the Kubernetes. Without Kubernetes, interview will not be completed. And in the interview, they will ask you to write this manifest YMLs. Got it. Now here, I have given the image name. Where is this image available? In my Docker Hub, this image is available. This is a public image. That's why Kubernetes is able to download this image from the Docker Hub. It is my public image. That's why Kubernetes downloaded my public image. Clear? So what is the work process I have done here? Working procedure. What I have done now, I created pod manifest and created the pod. Write pod manifest YML, create the pod using kubectl apply command. Okay, check pod details and pod logs. And in which worker node it is running. Write the service manifest. Create the service. Write service manifest YML, create service to expose pods. Check the service details and node port number. Check service details and node port number assigned. Node port assigned by Kubernetes. Okay. Enable node port number in worker node security. Access application using worker node IP. This is the working process. I have created pod manifest YML. Using that pod manifest, I created the pod. And I have seen the pod's information by using logs command and by using describe command -o-void. Then I have written service manifest YML and I created the service to expose the pods. And check the service details and node port number assigned by Kubernetes. It is giving some random node port number. If I delete the service and if I create again, another node port number will come. Tomorrow we will see how to fix that node port number. I want to use same node port number always. So today it is a random node port number we are getting. Enable node port number in the worker node security group. Access application using worker node IP. So this is what I have done today. I will update these class notes. From today onwards, you need to spend a lot of time for practice. I'm telling you, Kubernetes is not easy. Kubernetes is difficult. You need to spend your time, then only you will understand it. And this Kubernetes is damn important for the interviews as well as for your job. I'm updating the Kubernetes running nodes, whatever I'm preparing in the class. In that manifest YML is also available and the commands also available. Yeah, can you guys check it? The nodes is updated. Could you please confirm? Are you able to access the latest nodes? Yes. Now it's time for doubts. Yeah, please go ahead.
Ashok, I just want to ask one question. I just want to delete one IAM role. Actually, yesterday I tried to create the cluster setup till step 3rd. Okay, but for the practice purpose, I just want to delete the machines and IAM role. So once I tried to delete the machines like EKS client VM and the 2 worker node which have been created. So client VM was deleted, but this worker node was not deleted.
Worker nodes will not be deleted, sir, because they are in the cluster. So if you delete the worker nodes, again they will be recreated.
So what is the solution? Means I tried to delete.
You need to delete the cluster completely, not just worker nodes.
So how we can delete it? EKS.
EKS CTL delete cluster name will be available here also. In the AWS, your cluster is created, right? If you go to the AWS, search with the EKS.
Okay.
Elastic Kubernetes service.
EKS.
Yeah, you need to go here. This is your cluster which is created. You need to go inside the cluster. First, you need to go to the compute and you need to delete the node group first. Then you need to delete the cluster.
Okay. So all the IAM role will also be deleted? IAM roles and all that?
IAM role will not be deleted. Just your cluster and worker nodes will be deleted. IAM role will be available as it is.
So how we can delete it? The name for which
you can go to IAM. You can go to IAM service. In that IAM service role will be available. You can IAM role. It is free of cost. You don't need to delete that. You can create one more role.
Okay. Actually, Ashok, I am getting some error. So can I show just only for 2 minutes? Share my screen.
You can go to the IAM roles here. You can select the role which you want to delete. Here there is a delete option.
So that's it, right? No other roles we need to delete it, right?
No. Don't delete the other roles. Just go to IAM, search the role which you have created and click on delete.
Okay. Yeah. And one more thing, Ashok. This while creating the cluster, where the use of controller, manager, and API server, because we have seen that.
We can't. That is what I'm telling you. When you go for the managed cluster, you can't see this information. That will be taken care by AWS. Here, If you go here and if you search with the EKS, the cluster is created. We can see the cluster information, but we can't see that API server and all. This is our cluster. That is AWS managed cluster, not our cluster. If it is our cluster, we can see all the machines, but this is managing by AWS. They are providing as a service. You just need to create and use it. That's it.
Okay. Okay.
But
One more doubt, please.
Stored, the master node, where is it stored? Which host is it stored?
That, sir, master node we can't see. That is managed by AWS. That is the internal business of AWS. Why they will tell you where is the control plane? That is a service. They are charging money and they're giving you service. That's it.
Sure. We have written two manifest file, pods and service. But in the pods, we have mentioned label, and in the service, I think we have not mentioned the label, right? Why?
Selector. Pod label will be matching with the selector. Okay.
Sure.
Whatever the label is available in the pod, that pod label we will identify by using selector. Here there is a selector. Selector is this is the label.
Selector. Okay. And what is the use of hyphen here? Because we have not only
hyphen means list. Yeah. I will explain the YML. This is YML syntax. We'll discuss in the YML.
Thank you so much.
Okay.
One thing. Sir, please upload today video. By watching a video, I want to install also.
Yeah. Sir, why you want to wait for video to install all? Already document I have given very clearly, step by step. If you follow, you can set up the cluster, right?
Okay.
You don't need to wait for the video. You just follow the document. It is just a copy paste. Just follow the steps that I have given. You will be able to, same thing I have done in the class today, right? Just I followed the document. I created the cluster.
Yeah, Ashok, one question.
One question. Actually, we have already created a port, right? In the container port 8080 is there. Again, in the services also, we are configuring what is it, how we are mapping the services to this port. Here,
you will understand that tomorrow, sir. When I create a service, right, with the service type as a node port, Kubernetes will generate a random port number. We'll give it to our service. That random port we are enabling and we are accessing that. Tomorrow, I will tell you what is cluster IP, what is node port, what is load balancer. Tomorrow you will get the clarity on that part.
Okay, Ashok.
One question, Ashok, whenever you are doing the kubectl get pod, the running is showing the 1 by 1 and sometimes it is showing the 1 by 2. So what is that exactly? 1 by 1
by 2 means how many ports you want to create, how many are created.
Okay.
1 by 1 means I want to create one, that one is created, that one is running. If I give 2 ports to create, if it is 1 by 2, that means I requested 2 ports to create, but it created only one pod is not created. So that is the meaning of that.
Oh, okay. And the second question is, suppose that you are, whenever you are mentioning the meta, at that time you are giving the image, and image is downloading from the your Docker Hub. But in the actual organization, we cannot go for the public, right? We have to take it from the Artifactory.
Today is a first session, sir. Today is a first session. I will discuss all those things. Today I have shown you how to deploy one application. Okay? How to take that image from the private repository also we will discuss in the coming classes.
Okay, sure. Thanks.
So will you cover ECS?
Sorry?
Container service?
Sorry.
AWS has another service I heard that is called
ECS, Elastic Container Service. Instead of we are creating the Docker machines, by using ECS service, we can run the Docker containers. In the AWS classes, I will cover that.
Yeah, while creating pod, we can specify the node, in which node we can the pod should be created.
You don't have a control to decide the node details. So that will be decided by the control plane. In which node your pod should be created, you can't control that. That will be taken care by your control plane. That is EKS cluster will take care of that.
Yeah, randomly it will create in
randomly it will pick up the node and will create. Now, first pod I have created, it created in the first worker node. Now, if I create another pod, then it may go to the second worker node or it may go to the first worker node. We can't predict that.
Okay.
Yeah, Ashok, one quick question. Like I created that cluster and it created 2 nodes, but I'm not able to see the nodes in the EC2 dashboard.
You need to go to that EC2 dashboard and refresh that. You will see that. If the cluster is created, then definitely nodes will be available. If you go to the EC2,
I did that.
Here you can see the instances count. When you click on these instances, it will display what all the machines available there. Check it in which region you have created that. If it is a Mumbai region, you have to select Mumbai. If it is a North Virginia, you need to change the region.
EKS
Ashok,
client VM.
Yeah.
one more question. Like
sir,
for me, created like a T3 micro. Is it okay? Like instead of T2 micro.
T3 micro you have used. Yeah, that's fine. Okay, no problem. But charges will be there. You need to check with that.
Yeah, for me it is showing as free only.
Yeah, okay, then fine.
Ashok, this is Nagarjuna.
Today, when you deployed this application, you were trying to access it using the IP of that pod and container and the port directly. But I'm assuming when we do it like in production, there has to be some kind of a load balancer in front. You will cover that, right?
Yes, I will cover that, sir. I have given the service type as a load balancer. No?
Okay, sir. Okay.
Yeah. I will give the load balancer details and I will tell you how to map that to the domain name also. We will discuss.
Okay, okay. Thank you.
Hello, sir. Hello, sir.
Whenever I execute the command, I'm getting the actually command is not found like that. So I have created my virtual machine is the North Virginia. So I have provided the which one is you have provided given the command. So it's showing the command is not found like that. If you don't mind, I can share with my screen 1 minute.
Yeah, please share it. And make sure in which region you are creating the client machine. In the same region, your cluster should be created.
Yeah,
not
actually,
in different regions.
Yes, correct. Actually, it's disabled on the screen sharing. If you don't.
Yeah, you can do the share.
Okay. See, actually, I have created my virtual machine. EC2.
I can't see your screen, sir.
No.
Yeah, it's loaded. Yeah.
See, I have created the EC2 machine on the North Virginia region. See, 1 minute.
Sir, you are copying everything, man. So you need to copy the content after the dollar symbol, sir. That is a document in North Virginia $. Why are you giving that in the command?
Yes.
No.
You need to give from the EKCTL, right? In the document, you should not copy everything. So up to $, it is my information. After the $, EKCTL, from there you need to copy. Go to the document I have given. Go to the document I have given.
Yeah, 1 minute. 1 minute.
I have given that information. This command you need to execute for North Virginia. This command for Mumbai. You are copying the complete line. You should not copy the complete line.
Wait 1 minute.
Yeah. Meanwhile, other questions, guys?
Yeah.
Hello, sir.
Ashok,
Hello, sir.
like, Ashok, is it okay if we create a virtual machine?
By default, 2 nodes will be created if you don't give the node size. Okay. Yeah. Next one.
Ashok, is it okay if we create virtual machine in one region and cluster in another region?
Don't do that, sir. Create in the same region.
Sir, Pawan here. Yesterday, hello.
Yes, Pawan, tell me.
Sir, yesterday I created the setup, and when we stopped our EKS service, then automatically one of the node got terminated.
If the node is terminated, automatically one more node will come.
Okay.
Because EKS cluster will use auto scaling concept internally. If you delete the node also, one more node will come.
Okay, sir. Thank you.
Yeah.
Hello, sir. Hello.
Yes, sir.
Can you add access in nodes? No, I don't have access to that one.
Okay.
Hello, sir.
Yeah.
Sir, we have deployed our applications in Worker Node 1, sir.
Yep.
Yeah, but how can we guarantee that this application is highly available in the other nodes? Like,
so in future, we will talk about the load balancer, then you will get that clarity. Okay.
Okay, sir. Thank you, sir.
Ashok, hello, sir. In the YML file, we are specifying the port as 80, right? So what is the reason we are specifying as port 80?
No. When I explain the node port concept tomorrow, you will get more clarity on that. Okay.
Okay, sir.
Ashok, actually, I'm using the same command, EKS CTL that onwards, but it's coming, the command is not found like that.
First, install the EKCTL software in that machine. Okay. So I will upload the today's video, guys. Please go through that video and practice that. In another 1 hour video will be uploaded. Then you can see, Nagarjuna, what are the commands, what is the syntax I'm following to execute the commands. You follow that.
Okay? Yeah, okay, no problem.
Ashok, for the minimum and max node, the command which you have executed, We have not mentioned into that one.
I have not mentioned, then default it will take 2 as the worker nodes. 2
okay.
It will take by default.
So if I want some other numbers, then we have to mention
You
over
can
there, right?
do that. Syntax I have given. With that syntax, we can specify that.
Understood.
Ashok, in the real time, if you do all the things through automation, so how can we do the enable port number in the worker node, I mean, security group?
We will discuss that, sir. We'll discuss that.
Okay.
Okay.
Thank you. Thank you.
Fine, guys. Thank you. With this, I'm stopping for now. Please practice it. Don't delay the practice. If you delay the practice, tomorrow's session you will not understand. If you practice the today's concepts, then only you will get the clarity in the tomorrow's class. Please practice it on time. We'll meet in the tomorrow session. Thank you, guys.
Ashok, 1 minute, Ashok. Actually, I have installed that software also.
Yeah, please check it, sir. Tomorrow I will check the problem. I have another class.
Okay.
So you just go through the video and follow the syntaxes which I have given and install that.
Yeah, okay, no problem.